All right, this is just going to be a visual about arrays. So when you are using arrays, when you declare an array, I'm going to draw a memory map here. And we will start by just doing an array of strings, for example. So if I declare my data type is string, the name of my array is names, and the size of my array is 3. So what happens when I do that in memory is I will get an address right here where names begins. Now there are no strings in here because I have not put any in here, but this is names at index 0, and this is names at index 1, and this is names at index 2. So if I wanted to read in or if I wanted to assign a name, I could go to names at index 1 equals geo, and this is index 0, index 1, so then geo would be here. If I wanted to read in from the keyboard a name, of course I would prompt first, but into names at index 0, then whatever name was entered from the keyboard, say Tom, would go here. This is just a visual of this concept. This is not the programming part of it. That's in another video. The way that people usually draw arrays is like this. So this is my array. It's called names, and this is index 0, and this is index 1, and this is index 2. So then in here I have Tom is at index 0, and it's technically, I'll do it with geo, it's technically a character array, but because of the way strings are done, we don't need to actually worry about that right now. So all we want to worry about is the fact that we have an array, we are using the string, and as long as you include the string library and using namespace standard, you can use an array of strings the same way that you would use an array of any kind of array. All right, so now let's talk a little bit about searching an array. So we have this loop for int I equals 0, I less than count, and I plus plus. So we're going to assume that count is the number of filled elements in your array. And we're going to use an array of integers. So here's my picture of my array of integers. So I'm going to assume that, that's a very ugly box. Let's make a better box. This is my array of integers. My array of integers is called nums. This is index 0. So this is technically nums at index 0, which looks like this. Nums at index 0. This is index 1, 2, 3, 4. If the size of my array was 6, then it would be 0 through 5. So we'll just assume that the size is 6. And the count, we'll assume that the count is 3. It's very important to distinguish between what size is, that's the capacity, and what count is, because this is partially filled arrays. Count is the actual filled cells of the array. That's the count. The size is the capacity. So we're going to assume that we already have numbers in here. And so we already have numbers 52. Oh, I don't like red. That's ugly. let's use white, 52, 16, and 12. So even though our capacity is 6, our count is 3. That index is 0, 1, and 2. So our loop is going to go starting from 0 to 1 less than count. So if count is 3, 1 less than count is 2, and we're going to go 1 by 1. So if we were going to be searching the array, printing the array on the screen, filling the array, whatever we want to do, we just loop through and start at the beginning, which is I is 0, and 1 less than count. So if the count is 3, then we would go to 2, and we would go 1 by 1. And so like I said, we were going to be searching, so if we wanted to ask the user to enter a number, so we say cout, enter a number, and int target. So we would cin to the target. Then the user is going to enter some target, and say the user enters the target is 16. Now we wouldn't be asking for the target inside of the for loop. That would be done before the for loop. I just wanted to show you how I got this number 16. So the target is 16. Let's clean this up a little bit. So if we wanted to search, we would say for I equals 0, I less than count, I plus plus, if the name of my array is nums of I equals target. All right, so in this case, we have our target, which happens to be 16. And we're going to do the comparison. So we start out, I is 0, so we're going to go to nums of 0, and we're going to compare, does 52 equal 16? Is that true? Nope. So that is not true. So then I was 0, now I is going to change to 1. So now we're going to check nums at index 1. So I will change from 0 to 1. So nums at index 1 is 16. Target is 16 equals 16. And yes, that is true. And it is true because the target was 16 and the value at nums at index 1 is 16. So then we are going to do whatever we want to do depending on if we want to return the index. So the index then would be 1, and we could return that index, or if we were counting how many times the target was there, we would count it. Anyway, this is not the code. The code part is in the other video, and it's in the notes, and it's in the code examples. This is just a visual for you to follow along what's going on. All right, let's do some more visuals on arrays. So here is my array. I've declared this array called int nums, which is size 6. This is nums. Nums is a pointer to an integer. This is nums at index 0. This is nums at index 1, 2, 3, 4, 5. The capacity is 6. When I declare this, I also declare a variable int count, and I initialize that to 0 because I have not put any numbers in there. So once I put a number in there, I have to add 1 to count. When count is 0, that's right here, then count has the first place that I could put 1 in there. So I could write a loop to fill it, or I could assign values or do whatever I want. If I were to declare and initialize it and put 3 numbers in there, 1, 6, and 7. So if I declare it like that, that means right here I have the number 1, right here I have the number 6, and right here I have the number 7. So what would my count be? 3. So then 3 is going to be the first empty one. So that's why it's very important to remember that the first index in an array is 0, and the count is going to always be the first empty one. Now if the size of this is 6, I cannot go past it over here, like try to access nums at index 7, because nums at index 7 is out of the scope of my array. So that's something that you have to keep track of. And when we're doing partially filled arrays, always remember to declare your array and also declare a count that keeps track of how many elements are actually filled into your array, and that count must be less than or equal to the size of your array. All right, in the next video, we will talk about sorting arrays.